Bismillahirrahmanirrahim. Today I like to talk about polyhedrons and non-polyhedrons. So what are polyhedrons? Polyhedrons are three-dimensional geometric figures. We have three examples over here. This is an example of a polyhedron, this is an example of a polyhedron, and so is this. So what's common to all of them? You say, well, what makes them a polyhedron? Well, here it is. A polyhedron are three-dimensional geometric figures. They're three-dimensional geometric figures whose surfaces, all the surfaces, are polygons. That's makes pretty much sense, like polyhedron. So every surface is a flat surface and it's a polygon. If you remember the definition of a polygon, they're closed and the sides are each segments, etc., etc. So every surface of this three-dimensional geometric figure is a polygon. If you look at this one, this is a pyramid, right? And the pyramid has this particular, that's a base, and which is in this case a square. Why? Because I said so. Here we can make all the sides congruent like this. Now that's a square, and more like a square. So this is a pyramid, and you can see the base here is a square, and all of these other sides are triangle shaped. So polyhedrons are three-dimensional geometric figures where surfaces are all polygons. Now there's some terminology associated with polyhedrons, and I shall introduce that to you. So each side here, this face, a flat surface, that's called a face. So this every face, like that triangular shaped thing over here, that's called a face. So that's the face of this particular polyhedron. So there are this face, and there are four triangular faces, right? And this one too. So they're all faces. So now each of these pointed ends over here, that's a vertex. So here's a vertex, and here's another vertex, here's another vertex, here's another vertex, here's another vertex. So there are 5 vertices here. So plural of vertex is vertices. So each here is called a vertex. And each side, like over here, this would be like an edge. So right here, that's an edge. That's an edge. So this is called an edge. So we have faces, and we have pointed ends of the vertices, and we have edges over here like this. So an edge is like that. So that's an edge. So polyhedrons have vertices, they have faces, and they have edges. Now if you look at this particular one, so from here to here, that would be an edge. So here's an edge right there, and I'm going to just point out some vertices. That's a vertex, that's a vertex, and there are a bunch of vertices over there, and there are faces. Now here's a triangle, here's another triangle in the back, and the rest of them, they look like rectangles, right? So that's some basic terminology that is associated with polyhedrons. Okay, so here's a collection of some three-dimensional geometric figures. Not all of these are polyhedrons. Let's say which ones are and which ones aren't. We said the definition of a polyhedron is that all the faces are made up of polygons. Okay, so how about this one here? And that one seems to check out. All the faces seem to have polygons, and so does this one. That's a polyhedron. So that's a polyhedron, that's a polyhedron. Oh, this one is a nice looking three-dimensional figure. This is a cone, but a cone is not a polyhedron because a cone has a base. A cone has a circular base, which is not a polygon. That's one thing, and has this, like the actual cone, which is called the nape of the cone. Actually, it's also not a polygon clearly. So cone is like the, in a way, ultimate non-polyhedron. So cone is not a polyhedron. So there we go. How about this? This is a cylinder. So a cylinder is interesting, and you've seen cylinders before, I'm sure. A cylinder is or is not. What do you think? A cylinder is also not a polyhedron because here's a base over here, and it's a circle. Circle is not a polygon. So a cylinder, even though it looks pretty, it's not a polyhedron. This over here, this is a pyramid of sorts, and all the sides here seem to be the three-dimensional picture. We can only assume the other side is also like this, and that's a polyhedron. And so is this, because all the sides are polygons. And this is another pyramid. This is supposed to be a sphere, like a ball, you know, and it's like it has a waist like this. So a sphere is also not a polyhedron, because, you know, it's not made of polygons. And here we have this particular figure, and this too is a polyhedron. So of all of these, we have decided here that a cone, a cylinder, and a sphere, these are not polyhedrons. They're nice looking figures, but they're not polyhedrons. For polyhedrons, you have to have all the faces have to be polygons. Okay, so polyhedrons that we're going to study fall into two major categories, actually. So there are two types of polyhedrons that are of particular interest to us. First are pyramids, as you see over here. So that's a pyramid. Everybody's pretty familiar with pyramids. And the second type of polyhedrons that are of particular interest to us are called prisms. And these two over here, this one and this one, are actually examples of prisms. So now, what are pyramids and prisms? Well, pyramids are kind of intuitive. They have so the way the pyramids are defined, they have a base. This what the pyramid code stands on is called a base. So pyramids, they have a base like this, and then they have these side faces over here with a single vertex like on the top. So they have a base over here, and everything else goes up to this particular vertex at the top over here. So now pyramids are named based on the bases that they have. So here's this would be like this particular pyramid would be a square pyramid. Okay, so, and if you have a pyramid that's whose base is a pentagon, that would be a pentagonal pyramid. Pyramids are named according to the bases. This particular pyramid, the base here is a triangle, so this is called a triangular pyramid. This pyramid here, the base is maybe it's a rhombus, so it's a rhombus pyramid. If this base was a square, this would be a square pyramid. This is a pentagon. This is a pentagonal pyramid. And this is a hexagon. The base here is a six-sided, 1, 2, 3, 4, 5, 6 side. So this is a hexagon. So this is a hexagonal pyramid. So pyramids are named after their bases. Okay. So this is a triangular pyramid. This is a let's assume that this is a square. This is a square pyramid. This is a pentagonal pyramid, and this is a hexagonal pyramid. Now, a pyramid has a height. So the height of a pyramid is actually an imaginary line, so to speak, from here all the way up here. This is the apex, so the very top of the pyramid, from here to the base. So you have to draw a straight line here, and this would be a perpendicular line to the base, and that would be the height of the pyramid. So the height of the pyramid is the height as measured from the apex, this vertex over here, straight perpendicular to over here to the base. Now this over here, this is actually called the slant length of the pyramid, the length from here to here, which is on the face of the pyramid. It's this triangular face. So this is called a slant height length, or sometimes called a slant height, and this is called the height of the pyramid. The vertical has straight height of the pyramid. So it's very important to understand. So if you want to speak of the height of the pyramid, you're speaking from there to here, not the slant length over here, the slant height. So the height of a pyramid is from the vertex, the apex of the pyramid, straight up there. It's drawn to a perpendicular distance from there to the base of the pyramid. Here's another example here. Here's the base. This is a square pyramid. The height is from the apex straight perpendicular line. This is also called the altitude, or the proper height, they call it. What's the altitude of the mountain? What's the altitude of the airplane? It's straight height, how far away it is from the ground, so to speak. So the altitude or the height of the pyramid. This is called the slant length or the slant height, and that's from here to here. Now here we have a hexagonal pyramid over here, and that's the base, and the height is the perpendicular distance from the vertex to the base. It's also called the altitude, and this is the slant height of the side over here. So this is how we measure the altitude or height of a pyramid and the slant length or slant height of a pyramid. So in our particular picture here, if we wanted to measure the height of a pyramid, we would draw a straight perpendicular imaginary line from there to the base here, and we would suggest that that is a perpendicular like this, and that would be the height of the pyramid like this. I also wanted to bring to your attention that when you're drawing this, the edges that you don't see are marked by dotted lines over here, so they're behind over there. See, these are dotted lines to suggest that those edges are in the back that you can't see. Again, these two-dimensional figures have vertices and then edges like this, and then the faces, which are over here. Those are the three important terms that we need to know. So this is a square pyramid, that's the height. And if I wanted to draw a slant height, the slant length, I would go from there and to this edge over here, and this would be the perpendicular over here, and this would be here the slant height or length. So because this is the height of this triangle, see, right here. Okay, so that's how you measure the slant height or slant length versus the altitude of the height of the pyramid. So what are prisms? Now here's an example of prism. Here's an example of a prism, and prisms are polyhedrons. Prisms are polyhedrons that have two bases. There are two bases that are identical. So prisms have two identical bases. So they have two bases which are the same. They have the two bases which are the same or identical. And then the rest of the sides, the rest of the faces are parallelograms or like rectangles, because rectangles are like, special type of parallelograms. Okay, so rectangles are a subset of parallelograms. So prisms have two bases, and the rest of the sides are parallelograms or rectangles, because rectangles are special types of parallelograms. So here's the two bases. So there's a base over here, and there's a base over here, and the rest of the faces are, of course, in this case, it happened to be rectangles. In this particular figure over here, you can see this base is a pentagon, and then there's another base over here. The bottom of this over here, that's also a pentagon. That's a base number 2. So that's the two identical base, and the rest of the sides are parallelogram. It looks like they're also rectangles in this case, and they don't have to be identical. That depends on the side lengths of the bases over here. But there are parallelograms. In this case, they seem to be also rectangles. Okay, so prisms are polyhedrons that have two bases, and the rest of the faces are parallelogram. Now you must understand that bases are also faces, right? The special types of faces, because polyhedrons are three-dimensional figures that they're composed of all the faces, all the sides are polygons, and then the special circumstances being defining exactly what type of polyhedrons there are. Again, for us, two special types of polyhedrons are pyramids and prisms. Pyramids have one base, and the rest of the sides are triangles, and prisms have two identical bases. The rest of the sides are parallelograms. Now, polyhedrons can also be classified as follows. Polyhedrons can be classified as regular polyhedron and irregular polyhedrons. Regular polyhedrons are those polyhedrons where the faces here, they're all identical, they're all the same. In this case, all the faces here are triangles, and in this case, all the faces are regular, a regular pentagon. So this is an equilateral a triangle, and this is which is a regular triangle, and this is a regular pentagon. So regular polyhedrons where all the faces are regular and the same, the congruent polygons. So when all the faces are the same and they're all regular, that's called a regular polyhedron. Each face is a regular polygon. And so that's a regular polyhedron made up of regular polygons. Irregular polyhedrons, as you can see over here, all the faces are of different types. Here it's quadrilateral and etc., and they're all irregular. So this is an irregular polyhedron, where the faces are not of congruent or regular polygons. So irregular polyhedrons are made of irregular polygons. Regular polyhedrons are made of regular and identical polygons. And believe it or not, there are only 5 regular polyhedrons. That is, there are only 5 polyhedrons that are made of identical polygons. Okay, and they are as follows. And here they are. The first one is actually a pyramid, and all of the faces are the same equilateral triangle faces, and it's called a tetrahedron. A tetrahedron is a pyramid where all the faces are actually triangles of the same triangles. And this is a cube, of course, and cube is another one of these regular polyhedrons. And this one over here is octahedron. It has 8 equilateral triangular faces, and this one is very interesting. This is a dodecahedron over here, and that's a pentagon, a regular pentagon. And this one is also made of triangles. There are 20 triangles over here, and this is an icosahedron. That's it. You can't make any more of this. There's only 5 solids like this with regular polygons, and that's it. The interesting thing about this is that 3 of these 5, as you can see, are made of triangles. So triangle is actually a very versatile geometric figure, and you will see in construction of buildings, you'll see a lot of triangles because they're able to do so many things in the 3-dimensionally. So these 5 polyhedrons are very special, and they're called actually Platonic solids because Plato, the great philosopher and mathematician, used them in geometry proofs, etc. a lot. So these are the only 5 Platonic solids where the faces are all congruent. All faces are the same congruent irregular polygons, and that's tetrahedron, a hexahedron, which is a cube, octahedron, a dodecahedron, and icosahedron. And those are the 5 Platonic solids. So in your textbook, there is this particular figure that has all the formulas that you need to know to calculate the surface area and the volume of these particular polyhedrons. So here we have a prism. To calculate the surface area, now first you have to understand what the surface area is. The total surface area is if you were to add up the surface area of every single face here, for example, for area of that plus area of that plus area of that plus area of that plus all the sides. So if you were to calculate the area of every single side and then add it up, that would be the total surface area. And the perimeter of the P is the perimeter of the base. So if you wanted to find this total surface area, here you would just take the perimeter of the base and times multiplied by the height plus 2 times the B, which is the area of the base over here. Now, and so here's the formula for the surface area of the prism. For the volume, you have the area of the base, and then you would multiply it by the height over here. So if you want to kind of use this table to find the surface area and volume, you just kind of have to read what it says here. For a pyramid, this is the surface area is defined as 1/2 the P times L. So what is the P? The perimeter of the base, and L is the here the slant height, and B is the area of the base, kind of like that. So you can use this formula to find the surface area of each of these figures. Now, later on in the book, we're going to talk about all of these figures individually in much more detail, and I don't quite really know why you would want to do all of these particular complicated calculations in the first chapter of the book, unless you love the student very, very much, but here it is. So, but all the formulas here, and if you wanted to calculate the total surface area and the volume of each particular figure. And as I said, inshallah, we shall elaborate on this in the future in detail, but I thought I'd include this as a conclusion to our topic of polyhedrons. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.